Okay, welcome to seventh session of our design pattern course. You've done most of the journey. Well done. Thank you for being with us. You have our hosts today again, and we have right now even one more contributor, Anna. So you can see her. And thanks a lot for everyone for helping with questions and answers in our Slack, and everyone who contributed in our sessions as participants as well. So let's first start with recapping what we've done in the last session. Basically, we've done the look at iterator pattern and composite pattern. So let's start with iterator, what it could be useful for. Anyone would like to pick up this one? Yeah, Barbara?
Yeah, I can have a go. So I think the iterator pattern is, for example, a Kafka stream or any kind of workflow where you can first you take the first one and then you say how's next, and then you go to the next one, and then you go one by one.
Actually, it's good to compare with Kafka. It's indeed checking if there are any more elements in the stream. So it's indeed about checking what size of collection, if it has next, if like looking at the next element. Modern Java iterator has also a remove method, and you could play around. It's very interesting if you indeed could remove while you're iterating through the collection. Yeah, so basically to iterate through collection, whatever it's inside the application or outside of application, like you have messages from Kafka or RabbitMQ or some other message system. Good answer, thank you. And now, what is composite pattern? Who would like to take this one? Yes, Dennis?
I can try. I did like the example on the composite pattern in the Refractor website. It was a box of goods and a receipt, and the box was a composite of many items, and the receipt was the list. So you can have many items. This basically just it's a pattern of collections. So you have different collections, and you have a list of these collections where you can add and remove them. So yeah, I can't think. I mean, one of the examples is like when you order something and your basket has a different items, and I think it's almost the same principle. The composite, using the composite pattern.
Yeah, it could be add, remove, it could be any method that you can do with box and product inside this box. I also liked this example the best, and it's even easy to imagine you order a lot of things on Amazon, and sometimes it's a big box, but inside there are other boxes, and they all have items. Yeah. So example from this website was calculating the price of the item and of the whole box. So that's where a composite is showing up. So great answer, thank you. Okay, today we're going to start with a new pattern, which called state. First of all, it's a behavior pattern according to classic Go patterns, because we'd like to define what will be behavior depends on the state. If you looked at example in the book, they have this machine, Gumball machine, and when you look at behavior, it's completely different, depends on the state, if it has water or no water or salt. it's really different. Like every single message that is going to be shown on the display will be different in every single state. So that's very interesting example. And let's go to design group patterns. Let's check what they give us there. They give us here that strategy pattern is closely related to the concept of the state machine. So here, I would like to ask you, whoever worked with state machine before, whoever heard about finite state machine? Okay, several hands. Do not hesitate if you at least heard about it. So state, finite state machine is about describing your model in different, as a life cycle, basically. And we mentioned just recently box and product. So if you think about Amazon box, it has some life cycle. First, it's created because we've put some goods inside. Then it's dispatched for delivery. It's not yet delivered, but it's another state. Then it's delivered. And delivered is a terminated state, where like you can't proceed from delivered state. It's end state, so it's finite machine. Finite, which has just not infinitive state, finite number of states. And it could be lost somewhere. So when we design the system for tracking the Amazon boxes, we should say from dispatch, it could come to lost state as well. So we should treat it somehow as well. Also, we could return the good. So the box could be returned or product could be returned. In this case, we will introduce one more state, return state, that go after delivery state. Yeah. So when it's returned, it also could go to lost state. So that's interesting. You see, that's not like every state go to every state, but it could be different complication in this model. So that's about finite machine. Okay, here I have example of the document. It could be in draft, it could be under moderation, and it could be published. Here we can say that in different states, it could do this or that, and that's about this pattern. We implement interface, how exactly the model perform in its state, how it behaves, so its behavior pattern. And we implement concrete classes every time. And our context will be someone who work with our model. So in case of product and boxes, it could be Amazon. Amazon work with not only box, but also the state of the box. So that's idea around this pattern. And now let's go to example. I wouldn't go to example of Python here because every example on Python that I've seen so far is very abstract. Just request one, just request two, just say they just implemented class diagram. But if you look at Java example, it says that complexity of pattern is small because it's basically very straightforward pattern. You just move state in another class and you implement behaviors for state. I would agree with it. Popularity, it's a good question, and let's discuss this question a bit later. It says that we have some core libraries in Java that's already implemented state, only one actually, and it gives you one example. It says that we are going to implement player, and I'm going to go here. Actually, if you do all this on your laptop, whatever it is, Mac, Windows, or Linux, you will have a little bit different frames, but you can try to put everything from this example in Scratch file in Java, and it will work. It's beautiful, trust me. I tried it, and I like how easy it's to build with UI, with all these widgets. And I tried it because I wanted really to play and find out if this example that I like, to be honest. So let's see what is happening here. We have state, and we have different behavior. It could be on lock, on play, on next, and previous, which is basically our buttons. Yeah, so all these buttons, play, stop, next, ref, previous, it will give us some behavior, but what exactly we will look at will depend on state. So they say that state controls the behavior. That's the whole idea of state pattern. This pattern controls the behavior. Okay, let's start with locked state. So on next and on previous buttons wouldn't work if it's locked state. They would just return you locked. If we are on play and we click on play that it's locked, we say we move it to ready state. If we click lock and we play it, before we say stop played. Otherwise, they just give us locked because it's already locked. That's make a bit sense. Okay, ready state. On previous and next, it's actually the same. On lock, almost the same, but first we change state to be locked. Basically, we should have check if it's already, okay, that's fine. It's already in ready state. That's why we shouldn't check it. We just say now it's in locked state, and if it's play and it was ready, we change stage to be playing state, and we return play back, start playback. Also, yeah, and we need to first start, then change state, and then return what exactly is the track. If you try it, it will just return you track 1, track 2, track 3, and finally playing state. So we have 3 states. On next and previous, it's finally do something. Next, previous. On play, we can pause and put it in ready state. And if we click on lock, yes, we put it in locked state. And also we set track after stop. Okay, and return stop playing. Yeah. Okay, so if anyone spotted at least one problem with this management, and I would go to this line, to this line, to this line, to this line. Any ideas like what went wrong? Maybe what is inefficient here at those lines?
That you're creating many objects each time.
Yeah, exactly. So it seems like we could say that locked state, which pattern is it? Because it's the same. We could say it's singleton. However, we also give every time player. That's why we couldn't do this anyway, because player is different. So we actually create a lot of objects again and again, which I don't think it's good. It's kind of pollution of the memory. So I would say it's not a good way to control behavior like this. Another thing that I noticed that some statuses repeated their behavior, and that is not convenient. Like, why you still should use state as a pattern when you implement it? So I did changes. First of all, That's something they didn't put in the book. But you could define state as enum, and you can just say which is it, like without numbers. They used numbers, but they didn't refer to enum, which is a powerful concept in Java. Secondly, let me show how I rewrote this play. So I decided to check which is easier to maintain, this pattern state as they did, or my idea of pattern state. So I just say, again, we have unlock, and again, we're going to do the same as we did in the beginning of the chapter in this book. We're going to check what state is it. But look, unlock, we always put it in the state unlocked, locked, and the same that we see, whatever it's ready or play or locked. And we return that it's locked. Just if it was play before we do set current track after stop. That's what they did in the example. If it's play, it will be more different. And indeed, we have if else. However, now the question, is it easier to understand what is happening on play when you have all states in the same place? I think it's still easier in this case. Even if you need to do one more if else here, it's likely that you don't need it here because it's the same what you do on the locked state. And it's unlikely that you should change if else here because you can go to the next and previous lock track, only if you have play state. In other states, it's likely you can do next or previous, which means in this particular scenario, implementing it as Golf classic patterns will be overkill. Yeah, so here we just go with the only one edges. Mostly will be complicated with one, but again, if we have one more state, maybe it will be the same as ready or locked. Or maybe we shouldn't do too much code here. Yeah, let's see how it will evolve. But in these three statuses and in such a behavior, it still will be easy to not use this button. So popularity for me is very hard question. Did they mean the usage of the pattern itself in the classic way, or did they mean the usage of finite diagram of states, which is also the part of this pattern, important part to understand what are different states, how we can use them, how we can define them, and how we can change the behavior of the model depends on the state, how we can track the model through states. I did some changes which did what? Actually, I looked on the implementation that's at the end. I clicked on the buttons and I realized even on play that I said is the most hard method, it didn't make sense when I clicked on these buttons in the way how they implement it. I saw like, okay, on play could be only post. And if it's locked and you click play, there is no way to put it in ready state. You already wants to play, otherwise you need to click twice. So I would say they overcomplicated even business requirements to make the pattern to make at least more sense. But that's what we shouldn't do. That's what they will share at some point in the book. Like, do not try to go through patterns and apply it for business requirements. First, think how to simplify business requirements, and only when you see some repeatable behavior, then you can memorize some pattern and try to apply it. And we will talk today again like about how much like I personally, for example, used patterns even for decade of being development, like develop backend systems, like very similar that's described in this book. Okay, let's talk now about finite state machine. Here is another example. Now we think about models that says user model that's registered on the website. I think this is a very hands-on example that you could imagine, because I think every one of you registered at some point at some website, whereas they needed to verify themselves through email. And then after a year, they maybe needed to verify themselves again because the server wasn't going to store your data forever without usage it. So if we design authorization for users, even just user model in our application, we can have already 1, 2, 3, 4, 5 states, which is you trying to register. You are not yet verified because you need to go to email, but you already registered. We already know about you. So we already create a record in our database with you and with your email. We're just waiting for you to do this click from your email. So as soon as you verified, we put you in state verify. If you has not been verified in 24 hours, we put you in deleted state because we are not interested in users who are trying to fraudulent and attack us. Then, if you didn't use your account for a year, for example, we also put it in suspended because then we don't know, maybe someone then stole your email. And if you will try to use it again, we will unverify you again and then check out if you is still you. At least simple checks. If you will think about something, know your client model, know your business models, know your whatever model, that will be much more complicated to go through all verification checks. That's a very simple model, and that's indeed finite state machine. So if you imagine database with your records, you will have a column state, and this column will be responsible for states. And I think very regular point is to describe state with nums. Again, I would like to ask those people who already worked with finite state machine, did you use enum in Java to work with it? Okay, I see one yes and second here, yeah. Perfect. That's the one that we talked verbally, the same for delivered something. And if you go to source from here, after this session, you will get the presentation. You can click source and there will be a lot of other examples. So if you haven't been familiar with finite state machine before, you will see so many examples. So it will be easy for you to memorize. I decided to go to examples that we already looked at in session 4 when we talked about command. We said if we go to system design world, we can imagine that command is something you do as different services can execute. Yeah, and we could also refund, return the item, refund money, put product back in the stock. Yeah, in this case, we also cancel previous comments. That was our analogy with comment pattern. But another thing that helps us to track what is happening is finite state of the model. Yeah, we may have it all different models around. However, if we want to find out what was happening with product all this time, we have these statuses. Basically, the statuses will be here in create order, in cancelled order. It will track it here as well. So we will find out what's happening with the order from statuses through finite state machine again. That's analogy that I think we can use. Yeah, I already asked you. Thanks for answering. Another thing, it's more for discussion. And I would ask you, what is your thoughts here? We were talking about state pattern as a classic one and its behavioral pattern. But if you think about state pattern as idea of state machine, where you define how your model will behave in different states, what are states, and how we would track from creation to deletion our model. Then wouldn't it be more a creation of patterns than behavior? Who would think the same? Let's raise your hand if you would vote for this one. And you can share your thoughts if you think it's not. Okay, yeah, it's a raised hand. It's more like to imagine. I would say we can't rewrite the idea of Go pattern 30 years ago, but it's something for you to reflect and discuss with your friends and colleagues as well. Like you create a spike with discussions, and that will help you to memorize as well what was stated about and what you learned on this session. Okay. Now, for everyone who just learned it as well, for these two people, I think you will agree with me. But for everyone else, don't you think you've met this concept when you're a QC of software in your company? Oh, okay. More hands? Yeah. Perfect. Okay. It's perfect. That means that it's indeed a good concept. Okay, let's go to the next pattern. This will be our proxy pattern. Now we go to structural. So it will be less about behavior. It will be more about how we change the structure to achieve the same behavior. That's why it's structural pattern. I like this in this book, and I like that this Gumball machine went like chapter by pattern together. So it could already have some context. And now we had a CEO who wanted to see the states of Gumball machine remotely. And we did some code, and then we realized, remotely. So we have to clarify this requirement a bit in advance. Yeah. Basically, there was a lot of code base that I didn't put here that was about creating remote call procedures, invoking these state machines, etc. You can check out, of course, now, if we go here, we will see that the pattern is a bit more, I would say, more complex. Yeah. So because it's more actions around, more actors in the system. Yes, this pattern a bit more complex. So if you go to first description, it's very popular place where a proxy is using as a pattern, as a concept, as an idea. We always want to protect our database through proxy from how many actually clients can access at the same time. Yeah. So we have more actors here. That's why this pattern is a bit more complicated than others we've looked at. And let's go to another thing, relations with other pattern. Here we can proudly say we've looked at all these patterns during this course. And the first thing, oh, but isn't it another way as adapter? Isn't it the same? Actually, adapter, the difference that it has different interface, while in proxy you have the same interface. Yep. And you can enhance your proxy with decorator, indeed. So we now feel like, okay, patterns, they are not exist isolated, they can be combined together. Then we ask, what about facade? You already seen how we protect our API through facade in it, like why it's not facade the same. Yeah, it's both. They basically do this. But again, facade say we simplify interface. We may have under the hood several subsystems, while proxy say I do not have subsystem, my subsystem is the same. Like I just have a wrapper. Yeah, and again, when we think about wrapper, we think about decorator. Yeah, so similar structure, but a bit different anyway, because proxy is for only protecting, while with decorator, you can add any behavior above. Even like with decorator, I would think is it really structural or behavioral, because it's adding new behavior, it's adding login, it's adding authorization, etc. So for decorator, it's interesting if it's even not behavioral pattern, as they say, everything that's add behavior is a behavioral pattern, not structural one. So, but at the same time, I would be honest, I wouldn't implement this pattern in this classic way, in this like exactly the way where we do all these class diagrams. Yeah, however, I can say that I used cache as a proxy. We can say that any cache as caffeine cache in Java or Elro cache in Python is a proxy. And we protect our database from too many requests through caches. And also we improve our performance a lot through caches. So it's very good example of proxy. Not that intuitive, but it's indeed the example of proxy. So if you used ever cache, you used proxy pattern. Amazing, right? So here's the example with caching and YouTube cache proxies that they've built through hash maps. It's a good example, and I've put here a bit more examples. Let's do slideshow again. By the way, it's also good pages in this book because they say caching proxy, smart reference proxy, firewall, also proxy, because firewall protect you from the internet and do something opposite that's internet intended. And if we think about cache loader, this is very modern example for Java programming because it's used caffeine. And we can see how exactly we use this as a proxy. You see, like, I wouldn't even think about class diagram in this case because maybe a bit more complicated than you use it by hands. But basically, if you use something like this, it's already a proxy pattern, right? So that's already the idea to protect your main server from access from too many requests from anything. So that will be proxy. I also checked for Python. If you use Python, you know that you use a bit different decoration of your method through annotations. Yeah, and here is the example that I found for proxy. First, we wrote the proxy by the cache by ourselves. We write in the wrapper, and we check arguments. If they are already in cache, we just return it. If not, we apply some function that will be given us. Like in this case, it's get HTML data, which get requests by URL and give response back. So if you didn't find it in cache, we go to direct function and, for example, do HTTP request, which is very expensive, but if you don't have it in cache, we should do this, right? And we put result, and again, when we will get data by the same URL, we will have it from the cache. And yeah, another thing that you can use, again, built-in library, which will be Elro cache, for example. Yeah, last recently used cache. If you don't know what is it, I would recommend to read about it. It's sometimes even in interview. I was asked what is least recent used cache. It's a good question for interview. So last recently used cache, there is a Python ready annotation from func tool Elro cache. So it's already implemented in Python. And you do the same, like you just know that under the hood, it will use this URL If you don't have it yet executed and put in cache for this URL, it will go through main method. It will go through request get URL, and that's how decorator and patterns they use. They put another method above as an annotation. Okay, so that's good examples. If you go to system design, I would say there will be a lot of examples of proxy and how to protect your microservices, your services, your system, etc. So if we're talking about facade, we have only one example, which is API gateway that you put and simplify subsystems under one unique API where you put most of your security checks because you give it outside to business, for example, business to business API, always API gateway, always security checks, always load checks, a lot of things. That's why there is a whole market of API gateways. But with proxy, it's something even smaller. It's something like load balancer and Nginx, different reverse proxies, direct proxies, again, firewalls, DNS, CDN. A lot of things coming to me as examples. So I put tier one, but then you can imagine in your head as well what your word is. Could it be a proxy pattern? So you will get all this as system design examples. And now I would ask the same, especially for those who learn it today. Don't you think you meet this pattern or concept even every day? Yay, yay. Okay, we have so many. Okay, now you're very familiar with proxy and state. And that's it for today. So today we were quicker than even every time. Today was lighter session, but I really would like you to prepare for the next session as well. So you see, we've almost made it. Teaser for this book, it wouldn't have any more very detailed chapters on other patterns, like all of this amazing dialogue between patterns, files, chats, a lot of dumb questions, etc. That's question every single pattern that we've looked at. Unfortunately, they've done it. And that's coming to me this very interesting point. I was asking myself why they picked up these patterns, but didn't pick up some of them that they put in additional patterns chapter. So what I would like you to go through, I want you to go through all these additional patterns before the next session. So this one was quicker, shorter session, but next one will be, again, quite intensive because there is a lot. And only then we will go to compound patterns, combined patterns in real world. I think it makes more sense to first still look at all other patterns and then go to the chapter there, they compound, combined patterns, composite patterns. And we will speak about MVC. I already have presentation on it because when I read it, I had so many ideas to put in this presentation. So I built it at night with very huge excitement. So I would like you to go to it a bit later in the after the next session. And then we will close the close it with basically we're going to discuss about different design patterns that you could discover in your workplace. And after all this, the course will be finished, but you will have surprise in January. That's our teaser. Okay, now it was very good question last time, like which one I will commit it personally. So I reflected on it and I put there like X and checks where I would say, okay, this pattern, I implemented it, even like exactly implemented the ones that were described with class diagram, etc. Yeah, and these patterns I've never ever implemented. I wouldn't think I would ever have to do this. So that's my personal, but you can build yours. Again, all presentations successful. You can even copy it to your workplace, and you can put your checks and show your colleagues and ask them, like, what about your map? How your map would look like? Yeah, so let me briefly go through patterns that I've implemented. So strategy, for me, it's like just another like interface and different strategies. So yeah, it's kind of, I used it every day. Decorator, I had to implement it, but I would say here that it was very platform task for improving performance. So I needed to put timeout for API for endpoint to protect it. Yeah. And all that I'm sharing, it's all about my career experience. It's not about what I currently work on. It's all about like overall technologies that I covered in my career. Creational patterns, especially in my last workplace, I used them a lot because it was plain Java without annotations. Then comment. It's interesting because they say that Runable is a way to go through common pattern because you define some task, put it in Runable, and you execute this one, run this one. So they say that it's common. In this case, I used like Runable a lot. I know that it's using under the hood, but implementing something that will be commons of my API of the service. No, I didn't use it. Maybe even I had some ideas where it could be useful, but I'm not sure if it was the case. I didn't know this pattern at this point, so definitely I didn't use it like this. Adapter, like, as I said, the task where you will have to define SOAP interface for some legacy integration. Actually, it may happen, but I think I even saw this task in the backlog and find a way to avoid it. I said, I don't want this. Yeah, so I would say it still may take place because we still have legacy systems, and even we start to work for a company and that's evolving, and it's do more and more integrations. Some integrations will be with new high technologies, and some will be with very old. So you may need adapter indeed at some point to implement as in the way as a pattern is implemented. But still, it's like 1% or less of all tasks that you may need in your backend full stack journey. Facade. I put here that I think yes, but I didn't know that it's facade pattern because basically facade pattern, we simplify subsystems. So basically, if I needed to get something through API and then put data into database and I wanted to simplify it for some other invocation, invoker, yeah, then I would say yes, definitely at least once, maybe twice, maybe triple, maybe more. I used this as a pattern, but I didn't know when that I using this pattern. I just simplified the logic. Template method. Yes, again, without knowing that this is template method. And again, as we've seen in the session where we discussed template method, it was more like using it for static methods, not through classic diagrams, because it's easy to break risk of substitution. I seen even it was the task very similar to templating itself. So the idea was very similar, and they used classic way to approach template method. And then they had a lot of methods that other classes just throw an exception, like, sorry, I do not do this job. Yeah. So that was very good example of using template method that come into risk of substitution violation. I would say it definitely was something I was supported. I didn't implement it, but I already get it as a legacy to support. And I didn't know at this point that, actually it is exactly template method pattern. But like now I can tell for sure, like, yes, it's happened to see this template method, and still it's very powerful method, very powerful pattern, just it needs to be used very carefully. Yeah, when you have a lot of business logic that's repeat itself, it will be very useful pattern template method, but use it carefully, play around interfaces, and do not use too much hierarchy. Use composition over inheritance. That's the principle that they put in this book. Iterator. So implement by myself? No. In production? Yes, one day in the interview. I shared with you. I had to do it in the interview. So I wouldn't say like how many, how what else like to get from it. But of course, as a concept, we use it every day. So I would still encourage to understand very well how to implement iterator. Just for case. Composite. I think it's called pattern. I really like ideas. I've never had to implement it, unfortunately. I haven't ever worked with such a composite pattern, such a product project, such models, yeah, like where you have sub-models and they have to behave differently. The same, like menu items and sub-menus, etc. Or boxes and products and boxes inside. Actually, no, I think it's for specific models. That's why it will be rare that you will have to implement it. You need to first to find the business specific model to implement it. It won't be intentional. So don't be stressed if you, again, like didn't use most of patterns, didn't have to implement it. State, as they put it in this book, when state control the behavior. Now, I don't think I would ever use it in this way because, again, you need to meet the model where the behavior is so complex when they have 10 statuses and indeed every single of, 10 methods behave differently depends on the state. If it's the case, yes, this pattern will save you a lot of time and code. But would you meet this business model in the modern world right now? I couldn't even imagine the model like this. So it's a classic way. No, I've never used it. I wouldn't likely. It's likely I wouldn't ever use it. As a concept, as a creational idea, like when you define the model and you think about states, yes, like every day, all models I was working this, they have some finite state machine. They have clear point where it's created and where it's maybe deleted in life cycle. In this way, yes, but not as a pattern, as a concept. Proxy pattern, again, implementing proxy by myself. Even cache, we could think about cache as a proxy, but it's already implemented. So going through all these classes, etc. Now I didn't have to do this because most of proxy is already built in. Yeah. So again, as you see, like some of them in specific, very specific ideas and places I had to touch. But again, it's don't be stressed if you never have had to implement, especially if you work with Python, for you, like those patterns to work a bit different because you can use functional programming, functional functions as a first-class citizen that change the pattern, that change the idea of class diagrams. And for example, again, in Python, you don't have interfaces in the same way as we have in Java, for example, and other object-oriented languages. And the same for TypeScript, for example, yeah. It's also a lot of power of functional interfaces. A function is a first-class citizen. So you may use it in very different ways. That concept is cool. Yeah, so we more like learn concepts. We more like learn here what different software could be implemented and how fast. Let's go for additional patterns. So next lesson, next session, we will start with chain of responsibility. I liked it a lot because I had a very interesting business case in my career where I had to use exactly this pattern. It was different handlers, and it's indeed simplified my code base a lot. And I was grateful for my mentor who told me, like, it looks like we can do it as a pattern. Show me this Guru, Guru of Patterns website, and I used it. And it was an easier to maintain because every single handler of chain of responsibility could have absolutely different behavior, etc. And when you need to change only this one and don't have to change big classes, it's much easier to support and maintain. Other patterns, again, I put here that I didn't use them and I wouldn't ever likely to use them. And the last one, interpreter, it's very interesting. Guru Patterns website doesn't have this pattern. They forgot. They have 22. I was like, why I missed it? On the Wikipedia, you can find this pattern in the Go classic patterns. It indeed exists, and it exists in this book. But on this Guru Pattern website, they forgot. I don't know. It's more about building DSL for your business and use this pattern to transform this DSL to the logic that you're going to execute. I put here that I used it, but I didn't know this pattern. I indeed did some admin for some my business, some my internal clients, I would say, who did tasks to me. So they could do not come to me and ask me to build the file. They could build it by themselves with DSL. And I didn't know about this pattern, but I think I could build it a bit more beautiful if I knew about this pattern. So indeed. And I think that's could be the case because sometimes you come to business and they ask you to X, Y, Z, and at the end of the day, just like, okay, you could do X, Y, Z without me. I just need to give you some tool to do this because that's very similar. You just ask me to do some trivial changes in the system, but how we can like give it the opportunity to you to do these changes, not to me to do operational and the same tasks. Yeah, I want to do something, always different tasks, always more complex tasks rather than do the same tasks. So I would say interpreter may be a very good way to unlock these opportunities. And no one is thinking about it like this, so they put it in advanced patterns. And Guru patterns even skip this pattern. But again, it's more like idea what else you could do with software to improve your performance, business performance, etc. Yeah. So we're going to touch those patterns next session. We will be quicker with every one or every single pattern because they more rare indeed. They are not that popular strategy or proxy or observer, which is like now more system design. We also will discuss which one is now applied to system design. So that's what I want for you to do for the next session. For that, we will update that we're going to do these patterns because we built on fly like what exactly we want to do. And then we will do more like compounding, combining patterns, MVC. We will talk about MVC after next session. It all should be very interesting as well. So yeah, that's it. Here is your favorite resources. And if you have any questions, do not hesitate to ask us in Slack. And I stop recording right now.